You can build secure pipelines. You can automate testing. You can enforce policy. But at some point, something will go wrong. A dependency will be compromised. A secret will leak into a public repository. A pipeline token will be abused. A container image will include malicious code. The question is not whether incidents will happen. The question is whether you are architected to respond at DevSecOps speed. In modern environments, incident response must evolve alongside continuous delivery. If your response model is still built around quarterly releases and static infrastructure, you will be overwhelmed by the velocity of modern attacks. This lecture is about how incident response changes in DevSecOps environments and what you as a leader or architect must demand to stay ahead of disruption. Why DevSecOps changes incident response? Traditional incident response assumed relatively static systems. Servers were long-lived. Changes were infrequent. Infrastructure was predictable. DevSecOps changes that model. Now, code changes daily. Containers are ephemeral. Infrastructure is defined as code. Pipelines automatically promote artifacts. APIs connect dynamic services. If a vulnerability is introduced, it can propagate rapidly across environments. Your response must therefore be faster, automated where possible, integrated with pipelines, informed by continuous telemetry. Incident response is no longer an isolated security team function. It is an engineering integrated capability. In DevSecOps, detection begins before deployment. Shift-left detection means identifying potential compromise during code review, dependency scanning, secret detection in commits, pipeline validation, artifact signing checks. For example, if a developer accidentally commits a credential, automated secret detection should flag it immediately. Waiting until that secret is exploited in production is too late. Similarly, if a build pulls a malicious dependency, validation controls should identify the anomaly before deployment. As a leader, you must ensure that detection is embedded into development workflows. Prevention and early detection reduce response complexity. One of the most dangerous threats in DevSecOps environments is pipeline compromise. If an attacker gains access to your CI/CD system, they can inject malicious code into builds, modify artifacts, steal secrets, escalate privileges, distribute compromised software to customers. This is not theoretical. Supply chain attacks increasingly target build systems. As a leader, you must treat your pipeline as critical infrastructure. Incident response planning must include immediate isolation of affected pipeline components, revocation and rotation of credentials, verification of artifact integrity, rebuilding from trusted sources, audit of recent releases. If your incident response plan does not explicitly include pipeline compromise scenarios, you are underprepared. Secrets are the lifeblood of cloud-native environments. API keys, access tokens, service account credentials, database passwords. In DevSecOps environments, secrets exposure can happen through hard-coded credentials, misconfigured repositories, compromised build logs, leaked environment variables. When a secret is exposed, incident response must be immediate. That means automatic detection, rapid revocation, credential rotation, impact assessment, monitoring for abuse. Your governance must ensure that secret rotation can happen quickly. If credential rotation requires manual coordination across multiple teams, response speed suffers. Automation reduces damage window. Traditional SOC models focus on production environments. In DevSecOps, security operations must monitor code repositories, build systems, artifact registries, container environments, Kubernetes clusters, API gateways. Telemetry must flow from development and pipeline systems into security operations. If your SOC cannot see pipeline anomalies, you will miss early warning signs. Incident response maturity requires unified visibility across development and operations. Imagine discovering that a container image deployed last week contains malicious code introduced through a compromised dependency. Your response must include identifying all environments where the image was deployed, blocking further deployments, rolling back to a trusted version, regenerating images from verified sources, assessing lateral movement potential. DevSecOps environments allow rapid redeployment. That is an advantage if governance supports it. Your incident response plan must leverage automation to redeploy secure versions quickly. Speed can mitigate impact if controlled. Cloud-native systems are often ephemeral. Containers may terminate automatically. Logs may be short-lived. Instances may scale down rapidly. Incident response must account for log retention policies, centralized logging, immutable audit trails, snapshot and backup capabilities. Without durable telemetry, forensic investigation becomes difficult. Leaders must ensure that ephemeral systems still produce persistent evidence. Resilience includes auditability. In high-velocity environments, incidents escalate quickly. Your role is to ensure that clear escalation pathways exist. Executive stakeholders are informed promptly. Regulatory reporting obligations are met. Customer communication plans are predefined. Post-incident reviews are conducted constructively. Incident response is not only technical containment, it is organizational coordination. Leadership clarity reduces chaos during crisis. Every incident provides an opportunity to strengthen DevSecOps. After resolution, you should ask, why was the issue not detected earlier? Were pipeline controls insufficient? Were secrets management practices weak? Was access control too permissive? Was monitoring coverage incomplete? Learning must feed back into updated pipeline validation rules, stronger identity governance, improved runtime monitoring, revised risk thresholds. Incident response maturity is measured by how quickly lessons become improvements. Incident response effectiveness depends on architectural design. If your systems are overly permissive, flat in network topology, weak in identity segmentation, centralized without isolation, then incidents will spread rapidly. Zero trust principles, least privilege access, and workload segmentation reduce blast radius. Architectural disciplines simplify incident containment. Prevention and response are intertwined. You must measure response performance. Key indicators include mean time to detect (MTTD), mean time to contain (MTTC), mean time to remediate (MTTR), number of secrets exposure incidents, pipeline anomaly detection rate, post-incident improvement implementation time. Metrics ensure accountability and continuous improvement. Without measurement, response quality degrades silently. What good looks like? In a mature DevSecOps incident response model, detection begins in development environments. Secrets exposure triggers automatic revocation. Pipeline compromise scenarios are rehearsed. Artifact integrity is verified regularly. SOC monitors development and production telemetry. Incident communication protocols are defined. Post-incident lessons update pipeline controls. Architecture limits blast radius. Executive dashboards include response metrics. Incident response becomes integrated, not reactive. Ask yourself, does your incident response plan include pipeline compromise scenarios? Can secrets be rotated quickly and automatically? Does your SOC have visibility into CI/CD systems? Are artifact integrity controls enforced? Are forensic logs retained sufficiently? Are lessons learned consistently implemented? If the answer to any of these is unclear, your DevSecOps environment may be more fragile than it appears. Preparedness reduces panic. If this lecture has reshaped how you view incident response in DevSecOps environments, act decisively. Review your incident response playbooks. Add pipeline compromise and secrets exposure scenarios explicitly. Ensure telemetry integration between development and security operations. Test your credential rotation process. Validate your artifact integrity model. Do not wait for a breach to test your assumptions. If you found value in this session, subscribe to the DevSecOps for Leaders playlist, like this video so it reaches more leaders and architects, and share your experience in the comments. How prepared is your organization to respond to a DevSecOps related incident? In the next lecture, you will explore culture, people, and security champions, and how human factors determine DevSecOps success.